Very warm welcome to virtual classroom. Myself, Ant Emmanuel from Department of Chemistry, St. Francis PU College. Hope I'll meet you all to this virtual classroom. And I'm going to take the first chapter of organic chemistry called haloalkanes and haloarenes. So this chapter needs to be taught a connectivity from the first year chapter, that's hydrocarbons. I'll just relate it to the second year, haloalkanes and haloarenes. This chapter, haloalkane and haloarenes, have a connectivity from the last year's chapter called hydrocarbon. Of course, IUPAC nomenclature also will play a vital role for you to understand the chapter very clearly. So, the chapter haloalkane, haloalkanes and haloarenes. Haloalkanes and haloarenes. Haloalkanes and haloarenes. This chapter has two branches. One is haloalkane and haloarenes. Now, arenes are aromatic hydrocarbons. Arenes are aromatic hydrocarbons. You know, alkanes are saturated hydrocarbons. Of course, both come under same category of hydrocarbon. In that one, we have halogen derivative of alkane, halo derivative of arenes. So, I'll discuss haloarenes later. For today's class, I'll discuss only about haloalkanes. So, coming to haloalkanes chapter, the importance of this chapter I need to tell you, because for the examination point of view, board examination point of view, the weightage of this chapter is 1 mark in first main. Along with that, the last main it carries 5 marks. Together this chapter has 6 marks. So, the importance for the students who really want to score 70 out of 70, they cannot ignore this 1 marks. Because if they ignore 1 marks, chapter becomes, the total marks become 69. Therefore, the 1 plus 5 becomes 6 marks. So, the chapter is very easy. Little bit of connectivity from the first year hydrocarbon chapter will make our journey very fruitful and meaningful. Coming to the definition of haloalkanes. So, coming to alkane, the very basic example I can take is CH4. The CH4, the name of the CH4 is methane. You know, if I could split and write the expanded form of CH4, and CH4 I can write carbon bonded to 4 hydrogen atom. Carbon bonded to 4 hydrogen. So, if I could replace one hydrogen atom by an halogen. If I could replace one hydrogen atom by an halogen X, where X is fluorine, chlorine, bromine, iodine. So, I can replace any one of the hydrogen atom by an halogen fluorine, chlorine, bromine, iodine. I get a compound called CH3Cl or CH3X, where X is an halogen. So, what definition tells us haloalkanes? Haloalkanes are derivative of alkane, derivative of halogens, where one or more hydrogen atom of an alkane is replaced by an halogen. Definition says one or more. For example, if I could write CH3Cl, I have replaced only one. In methane, if I take the methane, I have replaced only one. That means CH3Cl, called as chloromethane. Chloromethane. If I take two hydrogen atoms, that is CH2, Cl2, it is called dichloromethane. If I take 3, that is CHCl3, I can replace 3 hydrogen atom of an alkane, that is methane, I can get a trichloromethane. If I remove all the 4 and write CCl4, I get tetrachloromethane. So, the name goes tetrachloromethane. Therefore, the definition says it does not restrict only for one hydrogen, replacement of only one. It says one or more hydrogen atom of an alkane replaced by an halogen is called haloalkane. So, definition I repeat once again. When a replacement of one or more hydrogen atom of an alkane by an halogen is called haloalkane. So, I can replace 1, I can replace 2 or 3 and all the 4. So, depending on that, we have monohaloalkane, dihaloalkane, trihaloalkane, and we have tetra, or we can call polyhaloalkane. So, I will go definition wise with examples. So, coming to the first definition, we go for the classification based on the number of halogen atom. Classification based on the number of halogen atom present in a molecule. The first classification goes, that is called monohalogen derivative. Monohaloalkane. Monohaloalkanes. Now, what are monohaloalkane? The word says mono. So, coming to the monohaloalkane, there are only one replacement of only one halogen atom, that is we can write here. So we can say replacement or replacing one atom of hydrogen, one atom of hydrogen by halogen. Replacement of one atom of hydrogen by halogen in a molecule is called as monohaloalkanes. Monohaloalkane, or you call monohalogen derivative of alkanes. For example, we can write here CH3Cl. The name goes chloromethane. Chloromethane. This is called monohalogen because only one is there. In the whole molecule of CH4, I replace only one. If I take C2H5Br, it's called bromoethane. If I take CH3, CHCl, and if I write CH3, it is called 2-chloropropane. See the definition, the whole molecule of propane, I replace only one hydrogen and replace only halogen called chlorine. In the molecule of ethane, I have replaced only one hydrogen by bromine. In the molecule of methane, I have replaced only one with the chlorine. The definition says what? Replacing one atom of hydrogen by halogen in a whole molecule is called monohaloalkanes, or called monohalogen derivative of alkanes. Similarly, we can also have dihalogen derivative of alkane. This is an example. So as class is going on, I hope students will note down the notes somewhere, otherwise it becomes difficult for organic chemistry to deal. So hopefully, I hope students somewhere take a notes. At the end of the chapter, I do give some assignments for you, questions. So please note down here the molecule's name, because after a long time we are reaching back to you. So you may forget or you may have some doubts. So please see that you note down immediately. So the haloalkanes definition, the monohaloalkanes are replace only one hydrogen atom, and now we are trying to move towards dihaloalkane. Dihaloalkanes. Dihaloalkanes, or we also call them as dihalogen derivatives. Dihalogen derivatives. So the definition goes, it says the molecule can have two replacements. So I will go for definition. Replacing two hydrogen atom, in a molecule by halogen atom. So definition of dihaloalkanes are called dihalogen derivative of alkanes. Replacing two hydrogen atom in a molecule by halogen atom is called dihaloalkane. Of course, CH2Cl2, dichloromethane. If I write CH here, if I count according to IUPAC nomenclature, 1, 2 and 3. So first and second carbon atom have an halogen derivative. Therefore, it is called 1,2 dichloropropane. And so similarly, the whole molecule of propane, I have replaced two hydrogen by halogens. Similarly, if I go for third molecule, that is in the methane, molecule of methane, I have replaced two hydrogen by bromine. It's called dibromomethane. That means the whole molecule, I have replaced two hydrogen atom by an halogen atom. And the definition, replacing two hydrogen in a molecule by halogen atom is called dihaloalkanes. So as we finished dihaloalkane, and now I am moving towards the trihaloalkane, we call trihalogen derivative of alkanes. Of course, when I come to trihalogen derivative of alkane, replacing three hydrogen atom by a halogen atom in a molecule. So I can give a very good example here is CHBr3, that is we call tribromomethane. CHBr3 is called tribromomethane. Similarly, if I go for CHCl3, it's called trichloromethane. I am trying to replace three. The methane molecule CH4, I replace three, so called trichloromethane. Similarly, if I go, the name of this IUPAC name is tribromomethane. tribromomethane. The common name for this is called bromoform, and tribromomethane is the IUPAC name. Now coming to CHCl3, it is called trichloromethane. Of course, the common name is chloroform. So see here, the replacement was by 3 hydrogen atom by halogen atom. So this comes under a category of trihaloalkane. Similarly, if I go for polyhalo, that means we are going replacement more than 3 is called polyhaloalkane. I can give an example, that is CCl4, that is tetrachloromethane. Tetrachloromethane, you see the replacement is more than 3. So the replacement more than 3 in a molecule goes for a polyhaloalkane, that is, we call it the name of this molecule is carbon tetrachloride. The common name for this is carbon tetrachloride. The IUPAC name is tetrachloromethane. The IUPAC name is tetrachloromethane. So we have successfully trying to classify the number of halogen atom. Depending on the number of halogen atom, I have tried to explain the 4 classifications. One was monohaloalkane, second one was dihaloalkane, third one was tri, and fourth is poly. So what is the definition of mono? Just a replacement, the whole molecule, observe the whole molecule, may propane or butane or pentane. See, any one of the hydrogen atom is replaced by an halogen. Now coming to dihaloalkane, the whole molecule, observe, it can be the same carbon atom or the neighboring carbon atom or the first and the third carbon atom. Replacement, if there are 2 halogen atom, you can call it as a dihaloalkane. Similarly, if I go for trihaloalkane, I brought a very simple example initially. Later on, I will bring a complicated examples to convince you all. Just I have replaced 3 hydrogen atom from methane. So we call this as a tribromomethane, or we call trichloromethane. Chloroform, the common name is chloroform. I have replaced only 3 hydrogen atom of the same molecule, and by that I got a trihaloalkane. Poly, it goes beyond 3. That is, if I remove replacing more than 3, we will end up to a tetra, that is called polyhaloalkane, carbon tetrachloride. The next topic what we are going to land up is classification of monohaloalkane. See, where exactly the halogen is bonded is very important for us. Whether it's a primary carbon atom or secondary carbon atom or tertiary carbon atom, because as we move on this chapter, we will discuss questions where we directly go to the primary carbon atom, secondary carbon atom or tertiary carbon atom. So we must know where exactly the halogen atom is bonded. Now, first year hydrocarbon chapter, of course, you have learned primary, secondary, tertiary carbon atom. I think we have discussed this in the first year. RCH2 and R2CH, R3C. Now, depending on that, we have discussed primary haloalkane or primary carbon, secondary carbon, tertiary carbon. So now we are going to classify monohaloalkanes. So classification of monohaloalkanes we will try to learn. So just now we finished the classification of monohaloalkane, dihaloalkane, trihaloalkane and polyhaloalkane. After finishing the classification based on number of halogen atom, now we are trying to find only the classification of monohaloalkane. Of course, the formula for monohaloalkane, I can write it as CnH2n plus 1x. And if I still move further, if I could elaborate it, I can write Rx. You know, X is an halogen. X is an halogen. And remember, the R can be a, R is an alkyl group. R is an alkyl. So, X is an halogen. So, what is R here? Just we can see the R can be methyl, ethyl, propyl, butyl, etc. But now we are trying to find out where exactly the halogen is bonded to a molecule. But remember, only one halogen will be there. There will be only one halogen in the whole molecule. But our focus is to which carbon, which carbon the halogen atom is bonded with, the primary carbon, secondary or tertiary. Now coming to the primary monohaloalkane, because classification is under monohaloalkane, primary haloalkane, first degree haloalkane under monohaloalkane. The formula clearly tells us it is Rx. I'll elaborate now. That is, if I could write here CH3, CH2, X. CH3, CH2, X. We can call it as R, CH2, X. So there are two ways to define a primary haloalkane, that is primary haloalkane under classification of monohaloalkane. What is our classification here? Remember carefully here, the carbon which I am going to call a primary carbon should have only one R. Should have only one R. Such carbon atoms are called first degree carbon atom. Such carbon atoms are called first degree carbon atom. And to this carbon of first degree, carbon of first degree, the halogen is bonded, therefore it is called primary haloalkane or first degree haloalkane. So I can give plenty of examples here. I can give very simple example here. CH3, CH2, Br. CH3, CH2, we elaborate it and write, it comes like this, R, CH2, Br. The Br bonded is, Br is bonding to a carbon, the carbon has one carbon bonded to one more carbon and has two hydrogen. So we have two definitions. The carbon which has two replaceable hydrogen atom, or the carbon which has one alkyl group or one R bonded to, such a carbon is called a primary carbon. To that carbon, if bromine is bonded, it is called as a primary haloalkane or first degree haloalkane. An example, very simple example is bromomethane. Bromomethane is a very good example. Now, what is secondary haloalkane? What is secondary haloalkane or second degree haloalkane? Our task is to find out where exactly the halogen atom is bonded. Now, when I find out, the formula goes like this: R2CHX. R2CHX. That means we can make it very clear. That is carbon here. Carbon has two R group and one hydrogen. It has two R group and one hydrogen. Therefore, I can give an example. You see what this carbon is called second degree carbon. To that carbon, if halogen is bonded, it is called second degree haloalkane or secondary monohaloalkane. Let me give an example here. The example is CH3, CH3. I can write one more H here, and here I can call it as Cl. Or I can also write this compound is called 2. If I could write CH2 here itself, the carbon CH here only, if I could write here, the carbon here has two methyl group and one halogen. It has two R group and one halogen. Such a carbon is called second degree carbon. To that halogen is bonded. Therefore, the name of this compound is called, 2-chloropropane. 2-chloropropane. What is identification? The identification is to the carbon which is bonded, and the carbon has two methyl group, two R group and one halogen and one hydrogen. In other words, this carbon has only one replaceable hydrogen atom. What is tertiary haloalkane or tertiary monohaloalkane? The formula goes here, R3CX. R3CX. I could elaborate it. You can find here RCRX. R3CX. Now remember, the halogen bonded to carbon is tertiary carbon. Why I call it tertiary? The definition says tertiary carbon which has no replaceable hydrogen atom, or we say it has 3R is called tertiary, 2R is called secondary, only 1R is called primary. So 3R is called tertiary. Now for this, if an halogen is bonded, we call them as a tertiary monohaloalkane. Let me elaborate it and give an example here. CH3, 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 Cl. Of course, last year we have learnt about IUPAC nomenclature. Learning IUPAC nomenclature, longest chain rule you know already. So I will take the longest chain rule, 1, 2, 3. So remember, this chlorine bonded to carbon, this carbon is called tertiary carbon. So now to this tertiary carbon, the halogen is bonded, therefore the chain is propane, and the name of the compound is 2-chloro-2-methyl-propane. 2-chloro-2-methyl-propane. So in all these three examples we have come across, we are trying to learn one thing very clearly. Our focus is primary. Our focus is primarily on monohaloalkane. Of course, the whole molecule will find only one halogen, but the problem here is where the halogen is bonded is very important, whether it's primary carbon atom or a secondary carbon atom or a tertiary carbon atom. If it's a halogen is bonded to a primary carbon atom, we call it as a primary monohaloalkane. How to classify primary carbon atoms? Sir, see that the carbon is bonded only to one R. In other words, the formula is RCH2X. That means R is a methyl, ethyl, propyl, etc. But see that the carbon has two replaceable hydrogen. So either you can go through carbon having two replaceable hydrogen or carbon having only one carbon bonded to only one carbon, that is R, is called as a primary. Secondary is, see that one halogen definitely where it is bonded. If it is R2CHX, that is the carbon has one replaceable hydrogen and two R group, that is R2CHX. I give an example, 2-chloropropane, that is second degree carbon. For second degree carbon, halogen is bonded, second degree is finding out to R. What is tertiary? Tertiary is again only one halogen is there, but see where it is bonded here. It is bonded to 3R, that is R3CX. Carbon has no replaceable hydrogen atom, that means it has no hydrogen at all. R is there, carbon is bonded only to carbon, X is there, tertiary carbon is there. Therefore, I can give an example here, that is 2-chloro, 2-methyl propane. Of course, first if you have learnt about the IUPAC rules, from that we can take the longest chain rule. I can find two substituents, one is chloro, one is methyl. Going to alphabetical order, coming to alphabetical order, I have C first and M first, so I can go for 2-chloro, 2-methyl propane. This is how the classification of primary, secondary, tertiary goes about. But just now we finished the classification of monohaloalkane as a first degree monohaloalkane, second degree monohaloalkane and tertiary monohaloalkane. As we finished the just classification of monohaloalkane as a first degree monohaloalkane, second degree monohaloalkane and tertiary monohaloalkane. Now we will just move on to the classification of dihaloalkanes. What I told you long back, what is dihaloalkane? Dihaloalkane is replacing two hydrogen atom by halogen in a molecule. So in the whole molecule, we are trying to remove two hydrogen and replace with a halogen. Of course, we have come across, just now we finished the classification, but we have two families here. One is called geminal, gem dihalides or geminial dihalides. One more is called vicinal dihalides. Now, only thing what we need to focus here is there are two halogen, yes, there are two halogen, but are they present to the same carbon atom or a different carbon atom? Same carbon or different? You can come across here, it is RCHX2, RCHX2. Remember, R is a methyl, ethyl, propyl, butyl, let us not worry about it. Focus on HCH. See how many X is there? There are two X. That means here I can write here, if I could elaborate, CH3, CH, Cl and Cl. What is the logic here? The same carbon atom has two halogen. The same carbon atom has two halogen. The replacement has taken from the same carbon by two halogen atom. Therefore, the name goes like this: 1 1 dichloro, 1 dichloroethane. Now, it comes under a family called geminal or gem dihalides or geminial dihalides. The classification we are discussing under dihaloalkane, RCHX2, CH3CHCl2. See what is happening. For the same carbon, two halogen are bonded. For same carbon, two halogen are bonded. Of course, two halogen dihalo, but here it's called geminal dihalides. What are vicinal dihalides? Coming across here, RCHX, CH2X. What is happening here? Sir, we can find out the halogen bonded to carbon, but not to same carbon, for the first carbon and to the second carbon. We call in English adjacent. Adjacent is a neighbor. The next carbon, the immediate carbon. So the two halogens are bonded not to the same carbon like what we discussed in geminal, but we are trying to find out the carbon, halogen bonded carbon to first carbon. Again, the neighboring carbon, second carbon also we find halogen. The whole molecule has two halogen atoms, but the two halogen atoms are not to the same carbon, but to the neighboring carbon. Therefore, it is called 1, 2 dichloropropane. 1, 2 dichloropropane. So we are trying to learn the classification of dihaloalkane, where we focus on the presence of two halogen, whether to same carbon is called geminal, whether they are present to the adjacent carbon, the first and the next, the first carbon, second carbon is called vicinal dihalides. Of course, in this chapter, in the examination point of view, sometime they'll ask the IUPAC name, the first main. I told 1 mark is very important in this chapter. Sometime they ask about the IUPAC nomenclature. So I will bring about 10 or 5 at least today. When I meet the next class, again I will bring 5 more molecules to discussion of the IUPAC nomenclature. So of course, when we discussed last year in the first chapter, IUPAC nomenclature, haloalkane, it's then substituent. Therefore, here if I could write, it's called halogen derivative of alkane. So I use a word called halo. That prefix halo, chloro, bromo, iodo, fluoro will come before the parent name. So it is called haloalkane. Haloalkane. Let me start with the very basics, then I move to the further. So I told you, as I am dictating or writing on the board, make a note so that you will come across, and any doubt is there, you can reach us back again. So here, if haloalkane, that means here if I write CH3Cl, it is called chloro again, chloromethane. Chloromethane, I told you chlorine is a substituent. It's a prefix. Prefix comes before the root word. Last year we discussed about that prefix, root word and suffix. Prefix comes before the root word. Root word is meth. N is the functional group. Chloro is a substituent. So if I can go across the CH3, CH2, Br. The first carbon has bromine here. Therefore, you call, just we can write bromoethane. If I could go across again, if I could take an example here, CH3, CHBr, CH3, CH3. Here the second carbon, of course, IUPAC nomenclature, second carbon, we call it as 2-bromopropane. 2-bromopropane. So the name halo always should come before the root word. And if I go for one more, that is CHCl3, it is called trichloromethane. How many times it is there? 3. IUPAC says, count the number of substituents. It is trichloromethane. Of course, the IUPAC name, common name is called chloroform. If I go for CCl4, it is called tetra. Tetra means 4 times. Tetrachloromethane. Of course, I will bring still complicated molecules because we are just starting virtual classes. So I thought to start with a friendly nature. So I brought very simple molecules. When I come for next class, definitely I will try to bring little more complicated IUPAC nomenclature, because we need to focus on IUPAC nomenclature to tackle the 1 mark in the first main. So I will just brief once again this what I discussed now. So geminal dihaloalkane is replacing 2 hydrogen atom by an halogen atom. Geminal, you can find 2 halogen to the same carbon. Vicinal, 2 halogen to the neighboring adjacent carbon atoms. Geminal and vicinal. Now coming to IUPAC nomenclature, I told you prefixes, halogens are prefixes like substituents, like root word, prefix, root word and suffix. Prefix are halo. Halo is fluoro, chloro, bromo, iodo. So here first name, IUPAC name. Of course, the common name is methyl chloride. IUPAC says chloromethane, bromoethane, tetrachloromethane. Of course, you come across like carbon tetrachloride. Here 2-bromopropane, trichloromethane. So we have come after classifying the IUPAC nomenclature, after giving the IUPAC nomenclature of at least 5 simple, of course not very complicated, very simple IUPAC nomenclature we have just discussed. And now we are trying to give some assignment for you, because see, we are meeting you after a long gap of time. So I want to give some assignments to you. Of course, after this, after you finish off this, you can take a pic and upload in the link what we are going to give in our college website. After watching this video, you will have a link. You can write the answer, capture it, and just have to log in and just you have to upload your assignment. Very important, because unless and until you write and practice, organic chemistry becomes very difficult. So I will give few questions here. Give an example for monohaloalkane. Of course, after discussing the whole chapter, you must be able to at least to give me an example of monohaloalkane, give an example for a dihaloalkane, give an example for a trihaloalkane. Of course, I have given 5 molecules here. Just I finished classification of primary, secondary, tertiary monohaloalkane. In all the 5, you find only one, but I want you to classify it first degree, second degree, and third degree monohaloalkane. And of course, after completing the assignment, in the link below, I hope all of you will upload the answers. Thank you very much for your cooperation. Hope I'll meet you again at the earliest.